you could, or some of you may even solve this without having to go through the math of it. Anytime you have three sides of a right triangle that are all integers, those are called Pythagorean triples or common triples. Okay, so be on the lookout for those. Okay, so we saw right there, again, they could also be called Pythagorean triples. But these are right triangles in which all three side lengths are integer values. The most common ones are the ones that we just saw, 3, 4, 5. And then the next most common one is 5, 12, 13. Okay, both of these show up on the SAT and many of the standardized tests that you might take. Both will come in handy in any math class from here and beyond. Will oftentimes include problems that involve 3, 4, 5 common triples, 5, 12, 13 common triples, and then all the multiples of those. Right, now you can create common triples from any odd length. If you start with any odd number, I put the little pattern or the little algorithm for that in your book. But if we were just to take, I have the 7 and the 9 there, but let's say we take 11, so the next odd number. And you can create a set of common triples by taking any odd number and then following the steps listed on page 90. And so if you begin with that number and then you square it, so what's 11 squared? 121. Then you subtract 1 from that. So if we subtract a 1, we get 120. And then you divide this in half. So if we divide by 2, 120 over 2 is 60. That gives you your second number, or second leg. And then if you just add 1 to that, that's going to give you the length of the hypotenuse that fulfills that common triple. And you really aren't going to have to do this too much. I may ask you one question to come up with a common triple. But it's a real simple pattern to follow in order to create those. Right. The one other thing that you need to know about common triples that can help you in working through problems is, so again, odd numbers as the first leg length can yield common triples. However, if you have an even number, you can also find common triples by using the properties of similar triangles. So if you took a triangle, let's say that was a 3, 4, 5 common triple, and you doubled every length. These are going to be similar triangles, so that means there's also going to be triangles that have integer values. So if we double the 3, double the 4, double the 5, we get a second possible common triple that's based on this 3, 4, 5. So we have a 3, 4, 5. We have a 6, 8, 10. What if we tripled every side? We'd get a what? 9, 12, 15. And so that method or that way of finding multiples can also help simplify solutions or problems involving common triples. And again, this is where you'll very likely find these on the SAT, is some variation of a 3, 4, 5 and a 5, 12, 13 triangle that allow you to kind of use these common triples. And so here would be a couple instances where you might see, or where that might come in handy. If I gave you two sides, let's say 16 and 20, and I told you this unknown side of z, and asked you to find that side. Before you go through and apply the Pythagorean theorem, which again, it would work. I mean, if you took z squared plus 16 squared is equal to 20 squared and solve this, you would come up with the right answer. But it's not going to be one that you can do with mental calculations necessarily. You'll have to write some things out or use your calculator. However, if you look at the problem itself and you try to identify, are there any common factors between the two given lengths? What common factors exist between 20 and 16? 20 is 4 times 5. 16 is 4 times 4. So you have this common multiplier here, a 4, and it leaves your pattern of 4, 5. Well, that fits one of your common triples, right? It fits the pattern of a 3, 4, 5. So you know that this side z is going to have a number 3 from the pattern, and then what's the common multiplier going to be? 4. And so your answer winds up being 4 times 3, which is 12. So being able to go through and use the properties of common triples and multiples of them, it can simplify your work and allow you to do it with mental calculations rather than working through it with the calculator. Okay, so try taking a look at this example really quickly, please. And see if you can find out what A is using that same idea of finding a pattern, a multiplier, and then identifying the unknown. And what's a common factor that you can remove from both 10 and 26? So this is 2 times 13, 2 times 5. So you have this 5 blank 13. Is that one of your common triple patterns? Yeah, 5, 12. And so your common multiplier was 2. 12 times 2 gives you your answer, 24. Okay? So again, I definitely encourage you to look at that first. See if you can find and apply common triples or multiples of them before you move on to Pythagorean theorem, which again, we could have also used a squared plus 10 squared is equal to 26 squared. That is also going to give you the correct answer of 24. But it's just simpler if you can break it down.